Hello friends, welcome back to Embrace Solutions. Here I am Sanay George. Today we are going to make a power control system. These are the main features of our power control system. We can protect our home appliances, our equipments and everything from high voltage damage. And also we can protect our things from low voltage damage. The next one is Bluetooth interfacing. We can connect our mobile phone to the control system via Bluetooth and we can program the parameters like lower cutoff voltage, upper cutoff voltage, date, time and everything using Bluetooth. The fourth feature is we can switch off or switch on the entire power supply of your home from a remote location by sending an SMS from your mobile phone. The next one is there is a memory backup of last two failure conditions. We are storing the last two failure conditions in microcontroller and we can recall them by sending an SMS from your mobile phone. And you may get to know if there is a power supply failure or power fluctuations or any line disturbance in your home power supply through your mobile phone. Okay guys, then we can make a walkthrough on our hardware section. These are the core components of our control system. PIC18F452 microcontroller. This is the heart of our system. The next one is GSM module SIM900A. We are using this module for sending and receiving SMS to our system. Then the next one is Bluetooth module HC06. We can configure parameters of our system via Bluetooth. Then the buck converter, this is a DC-DC converter, 2 ampere capacity, so 24 volt input. We are using for regulating our supply. And finally this is our PCB. This PCB is my own design using Proteus software. Here you can see the display section and the control section made on a single copper cloth. Actually there are two design files separately for display section and the control section. Now we can take a look on Proteus design files. Then we are going to our hardware section. This is our power control system. We are opening the front panel. You can see the hardware wiring and hardware components here. This is our controller PCB. The major part of our PCB is PIC18F microcontroller. Then this is the RTC module. We are using to provide date and time information to the controller. This potentiometer we are using to calibrate the output voltage. We can scale and calibrate. Then buck converter, this is providing 5 volt to our control system. Then GSM module. Then power supply transformer using to power up our system, 12 volt 2 ampere capacity. The second transformer is the measuring transformer. We are using this transformer for measuring the input voltage. Then control relay. Control relay is switching AC input voltage to output. These are the AC input lines. Microcontroller is measuring the input voltage, and if the input voltage is greater than upper cutoff voltage or less than lower cutoff voltage, then it will switch off the relay. Then this is the display PCB, as you can see. And again this is a buzzer. The buzzer is used to provide a beep sound on high voltage or low voltage interruption. This is Bluetooth module we are using for configuration via Bluetooth. Then this is RS-232 converter PCB. Then selector switch we are using for selecting GSM, Bluetooth or RS-232. Okay, then we can take a look on front panel. There is a 3-digit LED display, 7-segment display. Then status LED indicators for low voltage, high voltage, 5 volt AC input and relay output. Then power on indicator for GSM module and Bluetooth module. Then selector switch for selecting GSM, Bluetooth and RS-232. Then reset switch for GSM and microcontroller units. This is the programming RS-232 D9 port. Okay friends, the next step is we are going to power on our system. Let me see. Okay, you can see the current voltage is around 230 volt. Output relay energized. Then first of all we have to program the parameters of our system. For that we are placing the selector switch in RS232 position. This is a RS232 USB converter cable. One end we are connecting to our system, the other end we are going to plug in our laptop, as you can see. Okay, then we can configure our parameters using RS232 terminal program. We are using Micro C Pro IDE for software programming. This is the UR terminal of our IDE. We are configuring 9600 baud rate and we are connecting. Then the LED become green color. Initially we are going to clear the EEPROM memory for microcontroller. For that we have to use EEPROM clear command, EEPROM CLR command, then send it. Microcontroller will give an OK message as a feedback. The next step is we have to configure the date and time. For setting the date we have to use date space set and send it to microcontroller. Microcontroller will ask for the current date. Just type the date and send it. Then it will ask for the month. Type the month and send it. The last parameter is year. Type the year and send it. Then controller will give an OK. The next one is time set. The command for time setting is time space set. Then send it to controller. Controller will ask for hour. Type the current hour. Then minute. And the controller will give an OK feedback. Then OK. The last and final parameter is limit set. Here we are setting lower and upper cutoff voltage values. The format is limit space set. Then send it to microcontroller. Microcontroller is asking for lower cutoff voltage. We are saying 170 volt. Send it. Then type the upper cutoff voltage. We can say it is 280 volt. Okay, controller is giving an OK feedback. These are the configuration parameters of our system. But the normal people are not much aware about the programming of RS232 or terminal configuration. For that we are providing a Bluetooth interface for programming configuration parameters. The next step we are going to configure the same parameters using Bluetooth. For that we have to remove the RS232 cable from our system. Then rotate the selector switch into Bluetooth position. You can see the Bluetooth LED is on. Just open your mobile phone, go to Bluetooth settings. Here you can see H06 is configured with my name. Click on pairing, type the passcode 1234. Mobile is trying to pair with the H06 module. Once the pairing is over, you can close the settings. Then open Bluetooth terminal program. A lot of Bluetooth terminal programs are available in Android store. Then download one. I am using serial Bluetooth terminal API. Open it. Then connect. Yeah, it is connected. Then do all configuration parameters as we did in RS232 section. Okay, we've done the whole things related with the configuration. Next, we are going to do some experiments from our system. We have to check the functionality of our system. Here I connected one incandescent lamp at the output pins of relay. These yellow wires are taken from the output terminals. So we can check the switching of output. Additionally, I mounted one potentiometer parallel to the calibrating port. So we can vary the input voltage from outside. Okay, we are going to switch on the system. System is on. You can see 226 volt. We provided 3-second delay at the startup. Okay, relay is on. You can see the lamp is glowing. We are varying the input voltage by turning the potentiometer. We configured the parameter upper cutoff voltage on 280 volt and lower cutoff voltage in 170 volt. We are increasing the output voltage by turning the potentiometer. We are increasing it from 226 volt to 233, and we are again increasing. Now 242 volt. It is reaching to 280 volt. Yeah, relay turned off when the input voltage is going higher than 280 volt. That is our upper cutoff value, and high voltage LED will also glow there. Again, we are going to reduce the voltage within the limit. Limit means between lower and upper cutoff value. Then again relay will energize. Voltage reducing. Yeah, it is now within our limit. Again, relay is energized and output is on condition. Next, we are going to test the lower cutoff value. We have set it into 170 volt. We are reducing the input voltage below 170. Yeah, it is reducing. Once it reaches 170 volt, then output relay will off. 180 volt, 179. It is reducing and reaching to 170. Yeah, output relay is off now. Correspondingly, low voltage LED will be glow there. Then we are increasing the input voltage into our limit, means between 170 and 280 volt. Then again relay will be energized. Okay, relay is on condition. Okay friends, now we complete on lower voltage and upper voltage cutoff conditions. And next we are going to switch on and switch off our system by using SMS. Okay, now the input voltage is reduced around 220 volt. As you can see, our home town is facing such a lot of voltage fluctuations, related issues are there. And so I am also increased the lower cutoff voltage up to 180 volt because a lot of instruments are designed for minimum voltage of 180. So our protection should be within the limit. Okay, then we are going to check the SMS facility of our control system. Here I am using my tablet for sending SMS and receiving SMS because its size is a little bit large, so we can see more clearly. I am going to send an off SMS to the control system. Just type off and send it to the control system. You can see SMS is sending. The balance message is showing there. Yes, the device is switched off now. And similarly, we can switch on the system by using an SMS. Type on command and send it to the control system. SMS sending. It will take some time because it's GSM communication. And now the system is switched on, so we can switch off and switch off our control system from anywhere in the world by sending an SMS. Next we are going to check the memory backup of our control system. For that we are using the same port. I am decreasing the voltage below the lower cutoff voltage, that means 180 volt. Below the 180 volt, around 174 volt, the system is shut down, and this event is recorded in the memory chip microcontroller, inside of the microcontroller, and I am increasing the input voltage and back to the normal condition. Around 222 to 23 volt, the system is again switched on. This event is also recorded in the control system. We can record the memory by sending a status SMS to the control system. The GSM module will prepare a message with the backup connect and send it back to our tablet. Now I am sending status to the control system. The message is now sending. Okay, balance message is showing. Now the GSM module is preparing for the backup message. It will prepare and send back to our tablet. You can see now the message will come. Yeah, we got the message. The message content is voltage is equal to 225. It means that the current voltage of our system is 225. And in the fourth line we can see 174 voltage at the time of 1328. It means that system voltage is gone below the LRV, lower cutoff voltage, at the time of 1328. And also in the third line we can see 223 voltage at the time of 1329. It indicates that system is recovered from the lower cutoff voltage, or it is our system bring back to the normal condition at the time of 1329. So we can see the last events that happened in our system is recorded in the microcontroller memory, and we can recall the memory by sending a status SMS to our control system. This is a great feature of our control system because we can check the power status of our home, whether the power is there or any power failure is there or any power fluctuations is there. Everything we can check from a remote location. Okay friends, hope you enjoyed the video. Thanks for watching. This is Anish Jor. Please subscribe and give me a like. Bye bye.